Okay, so today we are going to learn about the distance formula, slope, parallel lines, perpendicular lines, and the midpoint formula.
To find the distance between 2 points, one should set up a right triangle. So we can assume that this point labeled x2, y2, and this point is labeled x1, y1. And for our purposes here, this side can be A, and this side can be B. And because we know this is a right triangle, for all intents and purposes, we can call the hypotenuse here C. To find the horizontal distance from this point to this point, we know that that would be x2 minus x1, because it's from this x-axis, this point, to the point on the x-axis over here. To find B, to find the vertical length between these 2 points, it's the same thing, and it is y2 minus y1. So we know that A equals x2 minus x1, and that B equals y squared minus y1. And so usually we would use the Pythagorean theorem to find the hypotenuse. So we can go ahead and set that up. So the Pythagorean theorem, as we know, is a squared plus b squared equals c squared. So we know that c equals the square root of a squared plus b squared. Now, continuing this, we notice that this is very similar to the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. So we can just write that down here.
I can zero it briefly. Nothing
And since we have A and B up here, we can just plug it in, and that would equal the same thing here, which would be that.
Here we have a real-life example to put the distance formula to use. Here we have point 2, -1, and here we have point -3 and 1. So we make our little triangle.
Should we script it first? Or kind of split it first?
And make our and then we cut into distance formula D equals. Okay, so we have our points here. D equals square root x to the second point, which is 2, minus x to the first point, which is -3.
So, I mean, like, what do you...
Y equals 2, which is -1, minus put this together, and 2 minus -3 is the same thing as 2 plus 3, so 2 pi squared plus -1 minus 1 is -2 squared, which is 4. So -2 squared here. Same thing as 25 plus 4, which equals the square root of 29. So the distance from this point to this point equals the square root of 29.
How's it going? Let's get started. You can be like,
Up next, we have Gajanth and Nicole attending UCLA next year. He's here to tell us about slope. What's up, Lana? What is slope?
Dope.
Talk loudly.
So, on this coordinate axis, we have a point here and a point here. Assuming that this point is x2, y2, and this point is x1, y1. Enunciate? Okay. So to find the slope, we take the change in the y over the change in the x. So for the change in the y, we basically say that y2 minus y1. For the change in the x, we say that's x2 minus x1. And then when we put the change in the y over the change in the x, we get our formula for the slope.
Yeah.
Okay, so pretend we have these 2 points, one which is 6, 6, the other one which is at the origin, 0, 0. So to find the slope between these 2 points, as for the formula, we take the change in the y, which in this case is 6 minus 0, and then we take the change in the x, which is also 6 minus 0, and we find that to be 6 over 6, which is equal to 1. And that is our slope.
And what is slope, Gajanth?
And slope is the change in the y over the change in the x.
Wrong answer. What is slope?
Slope is dope.
There you go. Up next, we have Nick Hawley, pitcher and left fielder for the Los Angeles baseball team, attending Cal Poly next year. Nick, what are you teaching us about today?
Hi, we're going to learn about parallel lines today. And what parallel lines are is when the slopes of both lines are equal, like this. So as Gajanth just taught us how to calculate slope, we will do the same thing in order to tell if these lines are parallel. So the way that you do that is take 1 minus 0 over 0 minus negative 1. And that is y minus y1 over x minus x1. And that will come out to be 1 over 1. So that's the slope for line A. And now for slope B, you will take 1 minus 0 over 1 minus 0, which also equals 1 over 1. So these two have the same slope, therefore they are parallel. Perpendicular lines are also noted by making a square on the lines to show that they're 90 degrees. So now we know about perpendicular and parallel lines.
You want to go?
What do I think about the midpoint formula?
Yes, we are. You can see the formula is right here. The midpoint formula is used to find the midpoint of a line segment, which is located here at point M. Here's an example of putting the midpoint formula to... Can we start over? Hi.
No, you gotta go with it. We did it to our video.
Yeah, that's character.
Here's an example of putting the okay, start over. Here's an example of putting the midpoint formula to use. In this example, we're trying to find the coordinates of point M. To do this, we take the x coordinates of point A and B, add them together, and divide by 2. Then we can take the y coordinates of points A and B, add them together, and divide by 2. So we'll start by taking -2 and 5. And then divide by 2 for the x coordinate, and then for the y, -2 plus 4, and then divide by 2 for the y. Wait, I said that. Okay, here you get 3 halves. And when you add these, and you get 2 over 2, which equals 1. So the coordinates of point M are 3 halves and 1.
And then they stop.
Take it away.
Make sure you get a really good Oh, I think that's mine. Bartender says, we don't serve your kind here. And faster than light neutrino walks into a bar.